So before we start into the details of inverse trigonometric functions, okay, we need to first understand or recap what we mean by inverse functions, right? So who can help me do that? What do you mean by inverse functions? Or rather, inverse of a function? Or when is a function going to be having an inverse? Or how are we going to judge the invertibility of a function? See, so many things I'm asking. You guys are not even saying anything. Hello, guys. You can speak, no?
Yeah, but when I'm doubtful, I type.
You don't type, speak, no? Okay, so Maria, tell me, what is it that you just now texted me?
If a function is a one-to-one and a one-to function.
Yes, so you will say, boss, this two fellows, okay, some x and y, they're correlated, okay? How they are correlated? A function is tying them up, because a function is a special type of a relation, isn't it? Which is going to tie up this x and y in the form of ordered pairs, right? 1, 2, 2, 3, all that stuff. But there is something more to it than a relation, and that is that a function can be a one-to-one mapping, okay, and or a function can be a many-to-one mapping. Okay, so a relation that satisfies both these things is called a function. Correct, no, guys? Okay, if I am having a relationship which is like one to many, then we say, yeah, it is a relationship, but I cannot call it as a function. Are we good with this, guys?
Yes, sir.
Okay. Then we are talking about inverse of a function. Inverse of a function means we want to find out this fellow g, if he exists, such that if you take the y and put it on g, he is going to give you the corresponding x. Okay, so if I have something like x1, y1, x2, y2, something x3, y3. So if you take g and give him y3 as the input, he is going to return to you x3. And the g is defined on the second set. Okay, g is defined on the second set b. That means you can give y1, y2, y3, y4, whatever are the elements in the second set, you can give it as a parameter to g. Are you able to follow this, guys? And
Yes,
every input you give to g, he is going to give you the corresponding what do you call pre-image. This. Okay, and this g is if the g satisfies this, g is called g is the inverse. Okay, so we say g is f inverse. We have also seen in that relations and functions topic. Okay, if f of g is equal to if f of g is equal to ix iy ix and g of f of x is equal to iy. This is ix, this is y. Right? Then we say that G is the inverse of F. These things we already finished in the topic, right? So, do you understand? Do you agree, guys?
Yes, sir.
Yes, sir.
So this is a recap of what you mean by inverse. So in trigonometry, we are looking at this fellow. Okay, so we are looking at trigonometric functions. Okay, so when we say y is equal to sine x, okay, when we say y is equal to sine x, this is an example for a trigonometric function. And for the trigonometric function, we are interested to see how to define the inverse of it. Okay, so for example, x can be is any supposing this is A, this is B. Are there any restrictions for x? Can x be anything in the when you are talking about trigonometric function? Are there any restrictions to the value of x?
No, sir.
Okay, so x belongs to real number. Okay, so and what is y? You see, if you say x is equal to simple examples, you'll give 30. So sine of 30 as an angle, okay, is going to give you some value. What is that value? Sine 30 is nothing but half. So if you have a value 30, okay, so this is going to be mapped to the value half. If you have a value 60, that is going to be mapped to, these are known things which I'm telling, root 3 by 2. If you have a value 90 or pi by 2, if you are measuring it in radians, you will have the value 1, right? So when you use y is equal to sine x, for 30 you get answer 1, 60 you get root 3 by 2, 90 you get 1. Correct now, guys? So now the question is, if you want to find the inverse of this trigonometric function, y is equal to sine x is a trigonometric function, you want to find the inverse of that. Okay, so you are saying, okay, let that now be y is equal to sine inverse of x. Or you can call it as a, because I'm calling these fellows as x, you can say x is equal to sine inverse of y. It doesn't matter. If you look at inverse trigonometric functions standalone, you will say y is equal to sine inverse of x. But in this context, because I have already said this is like x1, x2, x3, okay, I can say this is x is equal to sine inverse of y, where these values are going to be the parameters for this function, which is the inverse of sine. Okay, so if you say, hey boss, this is the inverse, I'm going to put the parameter half, what will it return? What is the answer?
30.
30. Okay, if you say sine inverse of 1, it's going to be 90 or pi by 2 in degrees and radians. Okay, so this is what the sine inverse function does. It takes the value and it is going to return to you the angle. Is it all right, guys? This is also called arc sine. So if you look at some calculators, instead of sine inverse, you will have arc sine x. Arc sine is nothing but sine inverse. Are we okay with this?
Yes, sir.
All right. So this is the introduction of what you mean by inverse trigonometric functions. So for all the trigonometric functions, sine x, cos x, tan x, cosecant x, secant x, cot x, there are corresponding inverse trigonometric functions. Their inverses are available. Is it okay? All right. But there is a small catch to this. The catch is this. Here, you are telling me that if you want to define an inverse of a function, okay, then that inverse, invertibility, the question is sine x, y is equal to sine x, an invertible function? This is a question. Or in simple words, does sine inverse x exist? Right? So if you want to check if there is f has an f inverse, okay, what is it that we should evaluate whether f has an f inverse or not? What we should check? So my question is, are there any criteria? Are there any criteria for a function to have an inverse? What happened? Once again, I get a chat message. Maria, correct. If it is 1-to-1 and onto, okay. So we say that not all functions will have an inverse, bro. For a function to be having an inverse, it has to be a 1-to-1 function, and it also has to be an onto function. Only if both these criteria are met, okay, then this particular function, y is equal to sine x, cos x, sine x, cosecant x, they will have an inverse. Is it okay, guys?
Yes, sir.
And are you following this, ma'am?
Yes, sir.
All right. Now we have to examine, okay, if y is equal to sine x is satisfying this criteria for a 1-to-1 and onto. Okay, so we will do with some simple example. Okay, this is forward function now, so it's easy for us to find out. What is x? X can be real number. Okay, we say I will choose some values. Sine 0. How much?
0.
0. Sine 90. Sine 180.
0.
Oh, hold on. I should not put sine here. I should say 0 and I should say 180. This is all just theory to make you understand certain things which I'm going to teach you. If you don't understand this, it becomes difficult. Okay. So y is equal to sine x. This is a function. This is our all x bill. This is A. This is B. Our x is going to belong to A, which is a set of real numbers. And this is y. Okay. So we are seeing that array sine 0 is 0. Sine 180 is also 0. Then we tell sine 90. Sine 90 is 1. What about 270? Sine 270 is also 1. Correct, no guys? Take a calculator and check if sine 270 indeed is 1.
So it says it's -1.
Yes, sir.
-1, because this sine 180 plus theta, isn't it? Sine 270 is sine 180 plus 90, right? And sine 180 plus 90 means it will be in the third quadrant, first, second, third. And we know in third quadrant, sine is negative, right? Hold on. All silver tea cups. So here in the second quadrant and first quadrant, sine is positive. In the third quadrant, sine is negative. So sine 270 is actually -1. Don't take whatever I say for granted. So can you tell me any other value of the angle for which you're going to get -1? One angle for which you get any other angle for which you get -1.
Any 2n plus 270.
Hmm? Ah,
Or 2n minus 90.
So basically, you should add 360 and 270. So if you take 630, that also will have -1. Okay, so through this exercise, it's fine. For us, even sine 0 is 0 and sine 180 is 0. Like that, you will have multiple ones. You will have multiple -1s, multiple halves, multiple √3/2s. That means sine is not a one-to-one function. Because if you take the entire domain of x, which is x belongs to R, then we see that for multiple values of x, you are going to have similar values of y. That means sine is not a one-to-one function. Then how come sine will have its inverse? Because if you want to have inverse, definitely it has to be a one-to-one function. Are you able to follow this? Okay, so sine y is equal to sine x is not a one-to-one function. If it is not one-to-one, how can we have an inverse for that? Are you getting the gist of it? Similarly, cos also is like that. Okay, cos is also not a one-to-one function. Okay, does that mean sine and cos are not invertible? Okay, how can we define? So the question, the straight answer is yes. Till now, as per our definition, sine and cos are not invertible. Then the question is, how can we still go ahead and define an inverse for them? Because I want something called inverse function. Okay, for the generic case, they don't, because they are not one-to-one. But if I still want to go ahead and define an inverse, what can I do? What can be done? Okay, so this is something which we'll have to understand. Are you following this, guys?
Yes, sir.
That means we are going to have some restrictions in place. Okay, in a particular restricted case, we are going to examine if y is equal to sine x can be a one-to-one function and also an onto function. Okay, so we under that restrictions only we can define an inverse for it. Okay, I have some graphs and charts. I'll show it to you. These are called the domains, domain restrictions. For a specific domain, you will have inverse. Okay. Now, let's go back to PPT. So there are a couple of tests that are there. So when you talk about whether your function is having an inverse or not, right? There are two tests which are called vertical line test and horizontal line test. Okay, so if you are what do you mean by vertical line test? You graph the function. Okay, so let's take y is equal to 3x. Then you draw a vertical line. If the line cuts the graph in only one point, okay, then you say, hey, whatever graph you have is a function. Make a note of this. This is called the vertical line test. So for vertical line test, you have to first graph the function. You will say y is equal to 3x squared plus 4x plus 5. You have to graph it. Then you have to draw a vertical line on the graph. Any vertical line on the graph should cut the graph only in one particular point. Okay, if it happens, then you say, hey, this graph has passed the vertical line test. That means y is equal to 3x is a function. The relationship defined by y is equal to 3x is a function. Are you following this, guys?
Yes, sir.
Okay, so I will write. Do you want me to write it down for you, or you got it?
We got it.
You got it. Vaishnavi got it. Chaitri,
Yes, sir, I got it.
Maria.
I got it, sir.
Very good. Then the second part is the invertibility. It also vertical line is going to test for whether it is a function or not in the first place. Okay. The second thing is invertibility. So what this guy says, you reflect the graph. It doesn't. Don't worry if you don't understand it, but I'm just writing it down. Take a reflection of the graph along x-axis. Same graph along x-axis, take its reflection. So here you see the red line is the reflection. Red line is the original graph. You are just reflecting this around x-axis, means this. Okay, the blue line is the reflection of red around the x-axis. Okay, then what you do here, once again you draw the vertical line. Once again you draw the vertical line. You check if this fellow has one intersection or multiple intersections. Okay, here you see it is cutting, the vertical line is cutting the graph in more than one place. Okay, so take a reflection of the graph along x-axis. Once again, check for vertical line test. Okay, on the reflected graph. So this is the case 2 we are doing. Okay. If it passes here once again, in our case, it is failed. If it passes here once again, then such a relation, such a function, because we know already it is a function, then such a function is said to have an inverse. Vaishnavi, are you following this now?
Yes, sir.
In IGCSE, in 9th standard, they have stuff like this. They will give you one point in XY plane. And they'll say, find the reflection of this on the x-axis. Find the reflection of this around the y-axis. So there are many, you have reflection of this point, you have a reflection of line, okay, you have a reflection of graph. They learn the things in 9th, 10th itself.
So
Hmm.
even in ICSE in 10th grade, we had reflection
Yeah.
of a point.
Okay, very good. See, 10th standard, I have stopped teaching 3-4 years, so I've forgotten what is there. Okay. Then you say, yeah, to pehla graph dalo, then you have to reflect it. Can you tell me something simple for, finding the inverse? Okay. That simple method is the horizontal line test, because this is like two-step verification. First is you draw the graph, you see vertical line, then you reflect it, again do the vertical line. Instead of that, can I just take the original graph and draw a horizontal line? Okay, because the horizontal line here, if it cuts in more than one place, the vertical line in the reflection will cut in more than one place. Okay, so the horizontal line test in the original graph without the reflection, if it cuts in more than one place, that means it is not a invertible function. Are you able to follow this? I think I confused you a bit, no? Let's just clarify. Till here, did you understand? Huh? That is, Neha, are you following, ma?
Yes, sir.
So till now, what I have said is a two-step process. Okay. So first you take the graph, and then you verify whether it is a function or not. Then you take the same graph, you reflect it, and once again do the vertical line test. Okay. Instead of doing this 2-in-1, you take that graph, okay, and do a horizontal line test. No need for you to reflect it and draw a vertical line. Keep it as it is and draw a horizontal line. If this horizontal line is cutting in more than two places, more than one place, that means graph is not invertible. That function, the graph of, sorry, you can say the function is not invertible. Are you following this, guys?
Sir, but in a graph like that, it will cut in more than two places. I mean, it will cut in two places, right?
Which one?
If we have
This
sorry,
graph, na?
this graph.
Yeah, it is cutting. That means it is not an invertible function.
Okay.
So in both, so this is like a parabola, no? So
Yeah.
whether you are doing it, see, the question, now I am through the horizontal line test, I am checking for invertibility, okay? So that invertibility was a two-step process. So I had to do the reflection and I had to do a vertical line test. Cutting in 2 points, no, not invertible. I want to avoid the two-step. Keep the graph as it is, draw a vertical line here. It is cutting.
So then all parabolas wouldn't be invertible.
Yeah, correct. They are not invertible.
Okay.
Any parabola is not invertible. You
So
follow?
then how would you do this
Hold on. So
test with a straight line
yeah,
graph?
we are seeing that. We are seeing that. We are going to check that. Okay. So the horizontal line test is like a 2-in-1 hack. So what you would do is you will say, hey, you want me to check whether a particular graph is a function. So we'll do one small thing. I have are you able to see my browser now?
Yes, sir.
Okay, so this is like y is equal to x square. Okay. I don't know if you can write on this now. I can't. What about that ink, Kami and all? Okay, so Vaishnavi, my question to you is this graph a function?
Yes, sir.
Why?
Because an equation you've taken y is equal to x squared. So the function,
Just talk it in terms of the test. Is this red curve a function?
yes.
Why?
So because the function you've taken is y is equal to x squared.
No.
And here,
So
I'm not sure what kind of wording.
you don't know what that function is.
No,
The
no,
graph.
I'm not sure what. Yeah, that is the graph. That function is y is equal to x squared.
You don't know that. This is the graph. Is this a function or not?
Okay. Yes, because for every x value, there's a y.
You simply say it passes the vertical line test. Why? I will take this graph, I draw a vertical line anywhere on this graph. Isn't it? Because see, all these are vertical lines, ready-made available.
Yes, sir.
So the vertical line is cutting the graph in only one place, isn't it? That means I don't know. If you see here, it is y is equal to x square. Otherwise also, without even knowing what that expression is, I will be able to say that this, the equation that is giving this graph has to be a function because it passes the vertical line test. Are you following this, guys? Okay. Now the second question, is the function which is giving this graph an invertible function? What do you say for that?
No,
No. Why?
because it doesn't pass horizontal test.
That's all. Okay. So now with that understanding of horizontal, you don't need to reflect it and all that stuff. You draw any horizontal line, it is cutting the graph in more than one place. That means it fails the horizontal test. So the red curve is a function, but it is not an invertible function. Are you following this, guys?
Yes, sir.
Okay, so now what you can do, you can play around. You say, what about y is equal to x cube? Is y is equal to x cube a function?
Yes, sir.
Is it an invertible function? Is it an
Yes, sir.
It is an invertible function because whatever may be the, wherever you want to draw the line, okay, horizontal line, it will cut it only in one place. Okay, so y is equal to, I just put 0.01 because it becomes a bigger graph. I mean, it is wider. Okay, so I just did that. Okay, so y is equal to x cube is a function and it is invertible. Okay, let's look at anything else. You can say 3x squared plus 4x plus 5. The moment you put x square, you know that it is not. Isn't it? Yes, this is like a quadratic. Hey, 3x squared plus 45, 3x squared plus 4x, I said. Plus something, fine. Okay. So once again, this is a quadratic function, but it is not an invertible function. That's the invertibility you have assessed it by the horizontal line test. Are you guys following this?
Yes, sir.
And the fact that horizontal line test is a hack. The actual test is you have to reflect it and once again draw the vertical line. But if you draw the horizontal line here, it is the same as that. Whatever you're checking there on the reflection, that is the same thing you're checking in the original graph by drawing a horizontal line. So this is like a hack and very easy. That's why we only talk about horizontal line test. We don't say reflection and vertical line test again. Are you following this, guys? Now comes to the question about our trigonometric functions. I'll say y is equal to sine x. Okay, so is y is equal to sine x a function?
Yes, sir.
It is a function because wherever you want, you draw the vertical line. It will cut the graph only in one point. Okay, but what about whether it is an invertible function?
No, sir.
It is not. Reason is here, see, x-axis itself is cutting. X-axis is a horizontal line. And you see, it is cutting the graph in multiple places. So y is equal to sine x fails the horizontal line test. Are you guys following this?
Yes, sir.
Okay. So we shall now make a note. Okay. That y is equal to sine x fails the horizontal line test, and so it is not invertible. Are you following this, guys? Okay, so now comes the hack. If it is not invertible, then how can we still go ahead and define an inverse for it? Because we all know it's there in our calculators, and we have this chapter, okay, and we do know that sine inverse of 1 is 90 degrees. How do we do that? So the hack is this. We know that our function y is equal to f of x is equal to sine x does not pass the horizontal line test. So what we do is we restrict it in order to define the inverse. Okay, the restriction is this. Yeah, I know this is a snake that goes on forever, but I will do a chop here, I'll do a chop here, and take only a part of this graph, the one which is indicated in red. Okay, then I will say, don't take x belongs to R, bro. Restrict it, because here this is 0, this is some negative value, this is some positive value. Okay, this is like minus pi by 2, this is like plus pi by 2. Okay, so x belongs to R, you are chopping. Okay, and you're telling now x belongs to only minus pi by 2 to pi by 2. Are you following this?
Yes, sir.
That restricted domain, y is equal to sine x, this trigonometric function in this restricted domain will have the inverse. How do you know? Draw a horizontal line now. Draw a horizontal line now. Yes, it is cutting only in one. Why don't I want to draw this? Because, bro, from here onwards, you're not interested in the graph, because your graph is only from this point to this point. From x is equal to minus pi by 2 to x is equal to plus pi by 2. So within this region, you draw how many ever horizontal lines you want to draw. It is only cutting the graph in one point. Okay, so the same function y is equal to sine x in its restricted definition of x belongs to only minus pi by 2 to pi by 2 suddenly transforms into a function that will have the inverse. Are you following this, guys?
Yes, sir.
Yes, sir.
I will give you 1 or 2 minutes for you to make a note of this. When I was sharing my video, the internet was very troubling. So I kind of, yep, you can go ahead. In fact, 6:30 to 7:30, we need to have some more time. Neha, are we good, ma?
Yes, sir.
All right. Don't write down what I have flashed here. I'll just talk you through it. Once you know why, that restriction is coming into place, the rest of the thing is easy. All right. So we conclude by saying that the function y is equal to sine x under the restricted domain of x belongs to minus pi by 2 to pi by 2, okay, will have an inverse, will be invertible. It will pass the horizontal line test, will be invertible, and the inverse of that is x is equal to arc sine y, or x is equal to sine inverse of y. All right. Now, Maria, are you making some? Do you want me to wait?
No, sir. Go ahead.
Go ahead. Fair enough. So now what we do, we quickly check What does that mean, Ra? Inverse trigonometric function. We say arc sine half. Okay, so that is sine inverse of half. Sine inverse of half is going to return to you an angle which is pi by 6. Okay, sine inverse of root 3 by 2. Sine inverse of root 3 by 2 is going to give you 60 degrees, pi by 3. Okay, so when you say sine inverse of root 3 by 2 is pi by 3, okay, that means you know sine pi by 3 is root 3 by 2. It's like you take it that side. In our normal terms, we say take sine inverse that side. Sine pi by 3 is equal to root 3 by 2. All right. So that is how we define the inverse. So we quickly examine the restriction. Even cos x also in an unrestricted domain does not have an inverse because y is equal to cos x fails the horizontal line test. Okay, so here what we do, we define an interval which is 0 to pi for cos x for it to be having a inverse. Okay, so we say the domain restriction for cos x is 0 to pi. Is it all right, guys?
Yes, sir.
Okay, in that way, if you see, I have put a table. This is how our function tan x looks. If you take y is equal to tan x always operates between two vertical parallels. Okay, minus pi by 2 to minus 3 pi by 2 to minus pi by 2, pi by 2 to 3 pi by 2. These are the parallels. Within this parallel, it operates from minus infinity to plus infinity, the y values. Okay, so like that you keep on going, you will have repeatedly this kind of curves. Okay, these curves resemble a cubic function, y is equal to x cube actually. Okay, so here too, it will fail the horizontal line test. And for restricting it, for defining it, you restrict it between minus pi by 2 to pi by 2. Within that, we say that tan x also has an inverse. Okay, so now that you have understood this, what we need to do is quickly make a note of this table. Okay, so this is called the principal primary domain. I forgot the correct term for it. Hold on. Principal value. Principal value. Because see what happens is, as far as y is equal to sine x goes, this is the domain. Now when you're looking at sine inverse of x, this becomes the range, isn't it? Guys, are you able to understand this? Okay, so for y is equal to sine x, we restricted the domain minus pi by 2 to pi by 2. So when you look at from sine inverse point of view, this is the range. This will be the domain. Chaitri didn't follow this, no, ma?
No, sir, I got it.
You got it, no? Because we are doing ulta. So here we restricted it minus pi by 2 to pi by 2 as far as y is equal to sine x went. Okay. Now when you're looking at, if I can say x is equal to sine inverse of y, right? Then this fellow will take the value here minus 1 to 1. And this will become the range for that. So in terms of the inverse, okay, the whatever domain restriction we placed on y is equal to sine x, the trigonometric function, that becomes the range. This is also called the principal value. So whenever you are doing the sine inverse of x, whatever angle you are going to get, it should not be beyond this. Okay, then you are wrong. Because -1 to 1, all the values are coming within this -π/2 to π/2. So if you're doing some sine inverse of some value, okay, you should not get an x that does not belong to this domain. So, okay, so -π/2 to π/2 means you should visualize. This is 0, π/2, this is -π/2. So your angle should be in this part. -π/2 means from x-axis, you go in the opposite direction. Okay, so this is the realm of what do you call sine inverse of x. Whereas if you see cos inverse of x, it's 0 to pi. So cos inverse of x means this is x-axis, this is y-axis. This is the realm of cos inverse of x. 0 to pi. And sine and tan and cosecant, all of them are same, but in cosecant you have to remove 0 because cosecant is 1 by sine. Okay, so if you take 1 by 0, it is not defined. So you have to remove 0 as the from the range. Or in cosecant inverse, y is equal to cosecant x, cosecant 0 is undefined because it is 1 by sine 0. So in the range for cosecant inverse, you have to chop it off. Similarly, cos π/2 is 0. Okay, so secant π/2 is 1 by cos π/2, undefined. So when you're talking about secant inverse of x, you have to remove π/2 from the principal value. Wherever infinity is coming, undefined is coming, such values you have to remove. Okay, and cot inverse follows cos inverse. 0 to pi, 0 to pi, 0 to pi. For secant, -π/2 is knocked out. So build all these things because this you have to use. So you put in your mind, sine inverse, cosecant inverse, and tan inverse are -π/2 to π/2. Additionally, cosecant inverse does not have element 0. Cos inverse, secant inverse, and cot inverse, they are from 0 to pi. Additionally, secant inverse does not have the element π/2. Make that correlation. Maria Biju,
Yes, sir.
why a video of software?
Because I'm massaging my neck.
Massaging your neck.
Yeah.
Alrighty, now I will give you a break because Chaitri, why she keeps her hand like this, I understood. To prevent her head from falling off onto the book. If the hand is not there, the head will come and bang the book. Okay, so I'll give you a break. Please refresh yourself and come back. Yes, do some numericals. Find the principal value of each of the following. This is how the numericals will start. Cos inverse of √3/2. Okay. So how we do for this is you say, hey, let cos inverse of root 3 by 2, let it be some angle theta. Always start with that. It makes the life of finding the answers easy. Okay. Then what does this mean? Cos theta is equal to root 3 by 2. Then what will you say? Rack your brains and find out for what angle of theta this statement is true. Okay. You will quickly realize that theta is equal to 30 degrees, guys.
Yes, sir.
Pi by 6. So you say cos pi by 6 is equal to root 3 by 2. Okay. Then you have to do the check now. Is pi by 6 belonging to the interval for cos inverse? Okay. Then you say cos inverse के लिए क्या था? It is between 0 to pi, isn't it?
Yes, sir.
Okay, this is pi by 6. This 0 to pi means 0 to 180. Pi by 6 is nothing but 30 degrees. Yes, 30 falls in between 0 to 180. So whatever angle we got, pi by 6, is indeed the principal value. Principal value for our function cos inverse of x is equal to cos inverse of root 3 by 2 is our function cos inverse of root 3 by 2. Okay. Any questions, guys? Easy peasy lemon squeezy. Okay. Let's do one more. Very good. Find the principal value of cosecant inverse of 2. Okay. Then you again say let cosecant inverse of 2 is equal to theta. That means cosecant theta should be equal to 2. If you are comfortable, convert it into sine theta side by side. That means sine theta is equal to half. That means theta should be once again pi by 6. Correct? Right? And then you verify. This pi by 6, does it fall under the restricted domain? Right? What is for cosecant? Cosecant always also it is going to be between minus pi by 2 to pi by 2 without the 0, isn't it?
Yes, sir.
I didn't get a 0, so I am cool. And pi by 6 is between, pi by 6 is like 30. I'm just telling you in the mind. It is between minus 90 and 90, right? So no issues. So we say that pi by 6 is the principal value for cosecant inverse 2. Chaitri, are you good, ma?
Yes, sir.
Neha, Maria?
Yes, sir. Yes, sir.
Now we'll do sine inverse of minus root 3 by 2. Okay. So Here if you see, when you say let sine inverse of minus root 3 by 2 equal to theta. Then we say sine theta is equal to minus root 3 by 2. Correct? Huh? Then what will you do? This is nothing but sine of, what is it? Sine of what is going to give minus root 3 by 2? Simply you can say sine of minus 60, because we do know that sine of minus theta is minus sine theta. Can you do that?
Yes, sir.
Okay. So sine of minus pi by 3, that theta value is minus pi by 3, is equal to minus root 3 by 2. Okay. But now you see, this fellow, is he belonging to the interval minus pi by 2 to pi by 2? Quickly check that. Is it belonging? Why I put pi by 3? Sine root 3 by 2, right? Correct. This is minus pi by 3 means minus 60. Yes, minus 60 is between minus 90 to 90. Okay, you keep it as minus pi by 3 if you want, or if you're comfortable converting it and assessing. Okay, so you can directly say minus pi by 3 belongs to the interval, okay, minus pi by 2 to plus pi by 2. And therefore, you can declare minus pi by 3 as the principal value. Is it okay? So without this, how would you have done it? You will say, hey, root 3 by 2 and you're getting negative value. Okay. So you'll say, where will I get negative value of sine root 3 by 2? First में तो positive है, second में भी positive है, third and fourth will be negative. Correct, no?
Yes, sir.
Okay.
So it can be 2 pi minus, right?
Correct. So that means 180 plus sine of 180 plus 60 is equal to minus sine 60. Possible, na? Okay, 180 plus 60 is minus sine 60. That means sine of pi plus pi by 3. That is sine of 4 pi by 3. Correct? Are we right? Sine 180 plus theta is minus sine theta. Okay, so sine pi plus pi by 3, sine 4 pi by 3. So this is one option for us to give minus root 3 by 2. The second option is either 270 plus 60 or 2 pi minus 60, isn't it? Because fourth quadrant we want to address, right? So sine of 360 minus theta. 60 degrees, sorry. So, because in the fourth quadrant also, sine 60 is going to give you minus root 3 by 2. Okay, so 2 pi minus pi by 3 means actually it is, if you're measuring this angle is going to be minus pi by 3, or this angle is going to be sine of 5 pi by 3, correct? Okay, but again 5 pi by 3 does not belong to this interval minus pi by 2 to pi by 2. I'm just kind of telling you, okay, if you know from basic trigonometry, negative value means it is coming in third quadrant, fourth quadrant. Okay, that means these angles I could have given sine 4 pi by 3 indeed is minus root 3 by 2. Okay, sine 5 pi by 3 indeed is also going to give the value minus root 3 by 2. But both of them cannot be the answer to the numerical because they are not falling in the domain of minus pi by 2 to pi by 2. So the question is, how do I express this angle such that it comes in this domain? Okay, so the only way is you take it in the negative direction, say minus pi by 3. Are you following this, guys?
Yes, sir.
Okay, so the correct answer is sine of minus pi by 3 is the principal value for sine inverse of minus root 3 by 2. All right, let's do one more. Tan inverse of minus root 3. Do it and tell me. Tan 60 is root 3, no?
Yes, sir.
Is it okay, guys?
Yes, sir. Cos inverse of minus half. Find the principal value.
Okay, I would like to work with you, Vaishnavi. Okay, tell me how to do this.
So you know that cos 60 is 1 by 2. So similarly, you can say cos minus 60 or pi by 3 is minus 1 by 2. Am I audible?
Yes, yes. So you're saying cos of minus,
Pi by 3.
but we do know that cos of minus theta is cos theta. So it works for sine, but does it work for cos?
No. So it would be
Check. Don't come
120.
immediate. Two people have given wrong answer. Okay, can you just check this and type the correct answer once again? How do we solve this? Doing it for sine will work. Doing it for cos will not work. Maria says cos pi by 3. But we know that cos pi by 3 is half, not minus half. So what is going to give you minus half? Cos of minus theta always is going to be cos theta. Okay, so the simple way to do this now, you say, boss, I know minus of cos pi by 3 is equal to minus half. Do you agree? You take the angle, put minus in front of it. Okay, but you want, till now what we have done, you are telling sine of minus pi by 3 is equal to minus root 3 by 2, and you are declaring whatever is in the angle to be the principal value. We don't want a sign in front minus. We have to convert that minus into the angle. So how can we convert the minus into an angle here? Are you following what I'm saying? Cos of minus theta is equal to minus root 3 by 2. It's fine. So minus theta is the principal angle. So minus cos pi by 3 is minus half. How do I take the minus away from outside and make it a part of the angle?
So you can say pi minus pi by 3.
Cos 180 minus theta is minus cos theta. So this can be written as cos of 180 minus theta. Because when you write it like that, you get minus cos theta. This is the trick here in inverse trigonometric ratios. You tell him 7th standard में नहीं आएगा 9th से आएगा करके बोलो आनंद. Your brother only, na?
Yes, sir.
Wait and watch one terror fellow is there, old fellow, he'll come to you from 9th, 10th onwards. Okay, now what we do, we say cos of 3 pi minus pi, 2 pi by 3. And quickly check if 2 pi by 3 belongs to the domain of cos, which is 0 to pi. Because when you gave the answer minus pi by 3, Vaishnavi and Anna, both of you, you didn't check. Minus pi by 3 does not belong to the domain of 0 to pi. Does it? It doesn't. So you didn't do the domain check. Please be careful. Okay, here too, I am doing a domain check. Okay, as it belongs to 0 to pi, right? This is like 0.6 pi. I can say now 2 pi by 3 is the principal value. Okay, another way for you, I'm just equipping you and me also. Minus half is coming, no? So it cannot not be in the first quadrant. It has to be in the second quadrant or the third quadrant. Third quadrant, I'm not interested, bro, because whenever I say cos, I'm interested only in 0 to pi. In second quadrant, what is the angle for which I get minus half? Cos of 90 plus theta. Cos 90 plus theta is minus sine theta, isn't it? So cos of, because I want second quadrant, I used 90. So cos of 90 plus theta is equal to minus sine theta. What value of theta is going to give you minus half? Minus sine 30. Correct, no, guys? Are you following or are you sleeping off? Please be a little energetic. Okay, cos 90 plus theta is equal to minus theta. What is the what value of theta is going to give you minus half? Theta has to be 30 degrees, right? Sine 30 is half. So that means cos of 90 plus 30. 30 is nothing but pi by 6. 90 plus 30. Okay, so you check this. This will be cos of 6, 3 pi plus pi. Cos of 4 pi by 6. 4 pi by 6 is nothing but 2 pi by 3. So you can do it in this way, or you can use the commonsensical way. You can find out, how cos theta is equal to minus half means what? It can be in second quadrant or third quadrant. How you will get it? By using the identity. Are you following this, guys? Which identity gives me cos theta as a negative value in second quadrant? That means cos of 90 plus theta is going to give me a negative value, because 180 plus theta 2. Cos of 180 plus theta also will give you a negative value of cos. But that we are not choosing because that will belong to third quadrant and cos is only between 0 to pi. So I don't want to use this. I'll use this identity. Then I'll say, okay, I know cos 90 plus theta is minus sine theta. So this minus sine theta should correspond to minus half. So what should be theta? Theta is equal to pi by 3 minus sine pi by 3. Oh, if you want pi by 3, put it here. That means cos of pi by 2 plus pi by 3 is going to be minus half. Do it. And you will get this as 4 pi by 3 or cos of 2, 4 pi by 6 or cos of 2 pi by 3. This is another way, or simply the other way is minus cos theta is equal to minus half, or say cos 180 minus theta is equal to minus half. You already got this as minus cos pi by 3. So cos of 180 is pi, pi minus pi by 3 is minus half, 2 pi by 3. You will get once again. Both ways is fine. Are you following this, guys? Full energy down. Energy down means something has happened. Maria. Oh, Maria.
Oh, so
Chaitri stopped writing long time back.
No, sir, I finished writing.
Finished writing, no? Good. Similarly, let's do one more. Cosecant inverse of -1. It's easy only. Do this properly and tell me. Anna, you're right. Very good. I hope you are not texting it into the calculator and giving me the answer. Huh?
No, sir.
With your video off.
So my video is switched on.
Oh, no. Okay. I got answer from Vaishnavi and Anna and Chaitri. Very good. So Chaitri, what she did, she picked up a clue and tuck, 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 karke she calculated and gave it off. Neha, where has the good strain reached? Maria is being very smart. She has over-engineered it. And so has, oh, Anna has gone ahead and finished for cot also. Okay, Maria, you and I need to work. Okay.
Oh,
Cosecant
sure.
inverse. Aja. See, in your facial expression itself, I know. Neha also.
Okay.
Next, I want to have work with both of you, Neha and Anna, Maria. Come for cosecant inverse -1.
-1. I heard it -5.
Here, where -1, no?
Oh.
Okay,
Okay.
do it, and then we'll get back. Okay. Can you do it with me?
Yeah. Let cosecant inverse of -1 equal to theta.
Hmm.
Then cosecant theta is equal to -1. And cosecant theta is equal to cosecant of -π/2.
Yeah. So this means cosecant of minus cosecant π/2 is equal to -1. And if I want to get this minus inside, sine and cosecant are sine minus theta is equal to minus sine theta. So I can directly put cosecant of minus π/2. You understood, no? So if cos is there, means this is not valid. So you have to use pi minus of theta. Whereas for sine and cosecant, you can directly get the minus inside, because you know that sine of minus theta and cosecant of minus theta is indeed minus sine cosecant theta. So you simply say, Neha, how did you get ma 2 pi, 3 pi and all?
Mistake, sir.
I told you no.
I had to put divided by 2.
Different word only. Oh, like that. All right. Neha, shall we work together for cot inverse now? Let me just erase it and keep it for.
Yes, sir. So it's minus pi by 6. Theta is minus pi by 6.
Okay, cot theta, no?
Yes, sir.
Tan of 30 is 1 by root 3. Correct. So minus cot can I get cot inside? Can I do that?
Yes, sir.
Yes, sir.
Because cos of minus pi by 3 is going to give you an issue, but we have sine of minus pi by 3. Doesn't matter, isn't it? Because that will help us. That means this is the principal value. And of course, you have to check, is this minus pi by 3? What is the thing for cot? Cot follows tan, no?
Yes, sir. No, sir. 0 to pi.
Then we have a problem. We can't declare principal value. Can you declare this?
No, sir. It can be
What to do?
5 pi by 6.
Not 5 pi by 6. How do we get minus pi by 3 now?
Pi minus.
Are you able to see this one? Hold on. Cot has to be from 0 to pi.
It can be in the second quadrant.
It has to be in the second quadrant only because that is what is cot. So what identity will give us negative in the second quadrant? Cot of pi minus pi by 3. Correct? Huh? Because cos of 180 minus theta is negative, sine of 180 minus theta is positive. Okay, because of that, cot of 180 minus theta will be negative.
So, shouldn't cot of cot inverse of okay, it shouldn't be minus. Sorry, pi by 6 and not pi by 3.
What is tan 30?
1 by root 3.
It's a pi by 6 child, correct. Sorry, tan 30 is 1 by root 3. So cot 30 is root 3. 30 means pi by 6. Okay, that means this is going to be cot of 6 pi minus pi, 5 pi by 6. Or 5 pi by 6, which belongs to 0 to pi. This is what you have to check because see, when you got cos of minus pi by 6, you can't give that as an answer because if you don't know, by mistake, Hannah, please pay attention. Like for tan, no, we say minus pi by 2 to pi by 2. So we may think that as the base and say for cot, okay, minus pi by 6 for tan is okay. But because this is cot has to be between 0 to pi. That means this will not work. We have to change it to something in the second quadrant. Okay, so then you quickly check 180 minus theta works. So 5 pi by 6 is, this is the trick in what you call inverse trigonometric functions. Maria, are you able to understand now?
Yes, sir.
You have multiple angles which will give you the same value, but you have to choose that which is in the domain of the function. As per the definition for these guys. So we said sine, cosecant, and tan is minus pi by 2 to pi by 2 guys. The others are 0 to pi with some exceptions. Minus 0 and minus 90. minus 90. Yeah. Are we good, guys?
Yes, sir.
Now we step it up a bit. Okay, so after you have understood the significance of these identities in arriving at, okay, the principal value, we go ahead for cos inverse of half plus 2 sine inverse of half. Okay, the thing is same, but only thing is each of these you have to pick up the principal value. You have to take it independently. This also you have to take it independently. Pick up the principal values, finally plug it. Sine 60 is root 3 by 2. 60. Yes, Anna is right. Okay, so cos inverse of half, we already know. Sine inverse of half, no brainer, no need for any manipulation. 2 multiply pi by 3 plus 2 pi by 3 is nothing but pi by 3. Pi by 3 plus pi by 3 is 2 pi by 3. So we say the principal value for this function for the whole thing is 2 pi by 3. It's not for any one fellow alone, for the combined fellow. Are you good, guys?
Yes, sir.
We'll do one more simple one. Tan inverse of 1 at every stage when you're evaluating it, please ensure that whatever angle you're choosing, the value should be within the principal value. You're following this now? If
Yes,
you
sir.
don't do that, your overall answer will get wrong. Tan inverse of 1 plus cos inverse of minus half plus sine inverse of minus half. Are you getting tan inverse of 1 as pi by 4, guys?
Yes, sir.
Cos inverse of minus half is?
2 pi by 3
And sine inverse of minus half is?
minus pi by 6.
So one important thing for you, Anna, to remember, thank you for coming back to this world. See, in her earphones now, she listens to music, she patches other calls, lot of things she does, Gotala.
No, sir, I don't listen to music because if then I unmute, you will be able to hear it on Zoom.
But suddenly you went smiling now. Why did you go smiling?
Sir, my tenant, the small child, she started screaming at her elder brother like a lunatic. So her father came out and dragged her inside.
Ah. For everything you have to tell. Pi by 4 belongs to for tan inverse na minus pi by 2 to pi by 2. Like that everywhere you have to mention before you take the angle. Cos inverse minus half. Okay, you get minus, then you have to, like individual sums we did na, like that you have to mention this. Then you have to plug this in the final step. They would like to see that. Okay, don't directly write it like I have done. Neha, have a good mark?
Yes, sir.
9 pi by 12 what? 3 pi by 4. Okay. But no way.
Yes, sir. I gave another answer before because on my
I saw that. Now look at this fellow. Evaluate. Sine of pi by 2 minus sine inverse of try ಮಾಡಿ. Wrong. So first go for sine inverse of minus root 3 by 2. What do you get for sine inverse of minus root 3 by 2?
Minus pi by 3.
Okay. Sine inverse, sine inverse, sine inverse. Huh? So minus pi by 3 you will get. That means this becomes sine of 90 minus pi by 3. That is sine of am I goofing up somewhere?
No, so you're right.
Okay. Now, what is the value of sine 5 pi by 6 though?
So we can write it as sine pi minus pi by 6. And that will be sine pi by 6. And it will be half.
Because you can't leave it here. Evaluate means you have to give the value. You could have done it in a different way, but that I will teach you later. Okay, where you have sine and see this is like sine 90 minus theta. Sine 90 minus theta you know is cos theta. So if this fellow is theta, you have to find cos of sine inverse of minus root 3 by 2. You can do this, but you need little bit of more inputs for this, how to convert from one to the other. Okay. If you are able to write sine inverse of minus root 3 by 2 as cos inverse, then cos of cos inverse is theta. That identity I'll teach you, and how to express one guy in terms of others. Sine inverse as cos inverse as tan inverse, all that we will learn tomorrow. And we will do more sums like this, where outside is something, inside is something. Still you have to find the value. Alrighty, so don't worry, it is easy. Once you understood the first part and how you have to chop and find out the proper principal value. Everywhere principal value matters. Okay, so you remember minus pi by 2 to pi by 2, 0 to pi for the respective fellows, and properly do it. Everywhere you check whatever the answer you get, does it belong to that definition, domain definition? Select it properly, then you will not go wrong. Then some identities are there. All right. Chalo guys. See you. Tata. Bye-bye.
Thank you, sir.
Thank you,
Bye.
sir.
So
Thank you,
thank
sir.
Bye. Let's meet tomorrow.